So now let's take a look at limits at infinity, but this time we're going to use Geogebra to graph some of these limits. I'm going to start by inputting down at the bottom the function that we were looking at previously. The function f of x is equal to 1 over x. And let's look at Geogebra's graph of this function. We see this vertical asymptote behavior, so right when x equals 0, our function is undefined and it's going off towards positive infinity and negative infinity, but that's not what we care about today. We care about the end behavior, what happens as x gets bigger and bigger and bigger. So I'm going to move graphics view, and I'm going to shift this function to be a little more symmetric, and then I'm going to zoom way out. I have the ability, I have to go back to my arrow, to have the ability to shift my axis when I hover over this x-axis. I want to bring it in. So as x gets bigger and bigger and bigger, I can have x go all the way out till, right, 55,000, 500,000, and by this time you see that this end behavior almost disappears because it's so close to 0 in here. I can even zoom out on this axis if I wanted. How close to 0? Whoops. How close to 0 does it get? It gets really, 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 really close to 0, right? At this point, I'm up at 10,000 and I'm below 0.0005. Another way that we can analyze this is the graphical way to interpret the end behavior or the limit at infinity. We can go to our spreadsheet view, click on spreadsheet, and I'm going to input my x value. Let's say I want to know what happens when x is all the way up at, like, I don't know, 10,000. Well, this is going to be f of 10,000, but I'm going to label it as the column A1. And what do I get out? This says that it's 0 because it's so small. If I wanted to, I can go up to options and rounding, and I want a whole bunch of decimal places, 15 decimal places. You see that it's getting really small. And if I wanted to do x going up to, I don't know, 1,000,000 or something, by clicking and dragging this down, it shows that my values are getting really small. And this makes a lot of sense because our function itself is 1 over x. So if I plug in 1,000,000, the output is going to be 1/1,000,000th. This is the first example that I wanted to explore. Let's look at another example that maybe is a more interesting example in some ways. Let's look at the example. I'll get rid of the spreadsheet view, pressing X over here. Let's look at an example. G of x equals sine of x over x. This is a function that we've looked at in the past as well. I probably should have zoomed out back to our standard view before I did this. Here, I'll just scroll. So that we get a better idea of what's going on. Okay, let's get rid of our 1 over x function. I don't want to look at that one anymore. Now I'm just looking at this sine function. And recall, we know that the limit as x approaches 0, this function is going to have an output of 1. That's something that we saw in some of our previous sections. And we see that here. As our x values approach 0, our y values are getting closer to 1. Today we want to look at what happens as our x values go out towards infinity. We see that as they get out towards infinity, they keep getting bigger and smaller and bigger and smaller and bigger and smaller. But the amplitude of this wave decreases, meaning that it keeps wiggling around x or y equals 0, but it gets closer and closer and closer to 0 as you get further and further out. And again, I can drag out for sort of my infinity view, and you see this, the wiggling gets so minute that after a while you can't even see it wiggling anymore. And we can see that on our spreadsheet by changing our function. Instead of looking at f of a1, I want to look at g of a1 because g is the name of this sine function. So g of a1 shows me that this is a negative 0.0003. It's very close to 0 and it's honing in on that 0 for its end behavior. And if I get all the way out to 1,000,000, I will look at g of a2. At 1,000,000, it's oscillating around 0 and getting really, really, really close. So those are two different functions that have end behaviors that approach 0. let's look at a function that has an end behavior that doesn't approach 0. So for example, we could look at some familiar boring functions. We're going to look at a function like h of x equals 3x squared plus 2. And for this function, it's a parabola. And if I zoom out here, well, maybe I'll zoom in here. If I zoom out towards infinity, we know what's going to happen. Our values will just keep getting bigger and bigger and bigger, meaning that as x approaches infinity, our y values are both approaching positive infinity. And so we could say that the limit is infinity. That's sort of informal speak because really this limit doesn't exist as a single fixed number, right? We didn't get a single number like 5 or 10 or 0 for our limit in this case. So for this polynomial, our function goes off to positive infinity for both x getting towards positive infinity and x going towards negative infinity. And then finally, I want to look at one that's a little bit crazier. Let's see something like f of, maybe I shouldn't call it f because we already used f. Let's look at k of x is equal to 2x squared plus 3x minus 1. I'm going to put that in the numerator. And then in the denominator, I'm going to put 3x squared minus 5x plus 4. Let's think for a second. We have a polynomial on top that's degree 2 and a polynomial on bottom that's degree 2. This is a rational function. Do we have any predictions about what this function is going to look like? Maybe not necessarily. Let's go ahead and start by looking at the graph. I'm going to zoom to an appropriate viewing angle. Oh, I have to go to the move graphics view to be able to zoom. I'm going to pull my x-axis out and move so it's centralized. And let's see what happens when I graph this. That's funny. It's a function. It gives me this little squiggle in the middle. But I don't care what's going on in the middle. I want to know what is my end behavior. And it looks like my y value, as my x approaches infinity, my y values seem to be honing in on a single value that's a little below 1. And if I pull this to zoom out, I can see that if I zoom way out, look how the squiggle in the middle starts to disappear just because of rounding. We see by the time I get to 40,000, it almost looks like a flat line, and that flat line is exactly our horizontal asymptote. But what is that value? It looks a little less than 1 is what this y value is. Let's go to spreadsheet mode so that we can get a slightly better estimate of what our horizontal asymptote is. So I'm going to go to View, Spreadsheet, and I'm going to look at our function k, and I'm plugging in a1. K of 1 gives me 0.668. That's not really clear what that's getting closer to, maybe. I'm going to look at k of a2, 0.666, and maybe for good measure I'll plug in negative a million. No, maybe that's negative 10 million. And when I pull this down, it'll continue. That's also close to 0.666. Really, I think that it looks like it's getting closer to 2/3. And if I look at the rational function over here, there's a 2/3 that pops out of the leading coefficients of this polynomial function. So it's a logical choice of why that might be approaching 2/3. We're going to look in a little more detail at the algebraic analysis of these types of end behaviors in our next video.